Underneath the ruins of an ancient racetrack in Jordan, scientists just pulled DNA out of 230 skeletons, and what that DNA revealed is now rewriting the story of humanity's very first pandemic. This is not some vague legend passed down through old texts anymore. This is hard genetic proof, pulled directly from the teeth, of people who died in terror nearly 1,500 years ago, and it changes everything we thought we understood about how this disease actually began. For centuries, historians relied only on old written accounts to describe the plague of Justinian, a catastrophic outbreak that swept across the Byzantine Empire between the years 541 and 750. Ancient writers described entire cities emptying out. They described bodies piling up faster than anyone could bury them. But descriptions written by scared scribes are not the same as scientific proof. For a very long time, researchers could not say for certain which disease actually caused all that death, or whether ancient writers may have exaggerated the horror for dramatic effect. That uncertainty ended when a team of researchers from the University of South Florida turned their attention to the ancient city of Jerash, located in modern-day Jordan. Jerash was once a thriving hub of the Eastern Roman world, filled with grand colonnaded streets, temples, and a massive hippodrome built for chariot races and public spectacles. At its peak, in the 3rd century, this city was home to roughly 25,000 people, a genuinely impressive population for that era. But by the late 6th century, something had gone terribly wrong, and that population had already dropped dramatically, setting the stage for a disaster still hidden beneath the ground. Buried inside the collapsed chambers of that once glorious hippodrome, archaeologists discovered something chilling. A mass grave containing the densely packed remains of roughly 230 individuals, all seemingly buried within a very short window of time. There was no careful ceremony here, no individual burial plots, no dignified funeral rites, just body after body, layered on top of each other in a way that strongly suggests a society completely overwhelmed by sudden, catastrophic death. When researchers extracted ancient DNA from the teeth of these individuals, the results confirmed something historians had suspected for years, but had never been able to prove with hard evidence. The bacterium responsible was Yersinia pestis, the very same pathogen behind the medieval Black Death that would devastate Europe roughly 800 years later. This discovery marks the first direct genomic evidence of this deadly bacterium ever found within the boundaries of the Byzantine Empire, right near the epicenter of where the outbreak was first documented by ancient writers. But here's where the story becomes even more fascinating. When scientists compared the genetic strains found across all these different victims, they discovered something remarkably consistent. Nearly every single sample carried the exact same strain of the bacteria. That genetic uniformity is not just a minor scientific detail. It is powerful evidence that these people did not die from scattered, unrelated illnesses spread out over months or years. They died together, rapidly, during a single explosive outbreak that tore through the city with terrifying speed. Think about what that actually means for the people who lived through it. This was not a slow, quiet decline. This was a fast-moving catastrophe, one where healthy neighbors could be dead within days of each other, overwhelming any ability the city had to respond in an organized way. Archaeological evidence even suggests the grave was eventually sealed by an earthquake that caused the hippodrome structure to collapse on top of it, almost as if the earth itself decided to bury this tragedy and keep it hidden for the next 14 centuries. If uncovering hidden layers of ancient history like this fascinates you, go ahead and hit that like button right now. It genuinely helps more people discover deep dives exactly like this one. Now here's where the researchers went far beyond simply identifying the disease itself. Instead of stopping at what killed these people, they wanted to know who these victims actually were. This is where things take a genuinely unexpected turn. Scientists examined stable isotopes preserved inside the bones and tooth enamel of the victims, a scientific technique that can reveal incredibly detailed information about a person's diet and even where they grew up as children. Carbon and nitrogen isotope values showed that most of these individuals ate a fairly typical regional diet based largely on locally grown crops common throughout the ancient Levant. Nothing especially unusual there. But then researchers examined oxygen isotopes, preserved specifically in tooth enamel, and this is where the real surprise emerged. Oxygen isotopes act almost like a hidden fingerprint of childhood geography, based on the specific water sources a person drank from while their teeth were still developing during early childhood. The oxygen isotope values from these plague victims showed a surprisingly wide range, far more varied than what researchers typically see in long-term stable populations from other well-studied sites across the region, including places like Tel Dothan, Pella, and Fainan. In simple terms, this means many of these individuals did not grow up drinking water from the same local sources near Jerash. Their childhoods took place somewhere else entirely, in different regions with different water chemistry, before they eventually made their way to the city. This single detail completely reshapes our understanding of who actually died in this mass grave. These were not simply lifelong residents of Jerash who had lived there for generations. Many of them appear to have been migrants, travelers, or people who had relocated to the city at some point during their lives, likely drawn in by its reputation as a major trade hub along important ancient routes. In other words, this grave does not just tell the story of a local tragedy. It tells the story of an interconnected, mobile ancient world, one where people moved between cities constantly carrying goods, ideas, and unfortunately, in this case, a deadly pathogen as well. Ancient DNA extracted from these remains also revealed something about maternal lineages among the victims, tracing genetic threads that connect back to broader Byzantine Levant populations. Even though these individuals came from varied backgrounds and possibly different regions, they were infected by that exact same uniform strain of plague bacteria. This suggests the outbreak spread with brutal efficiency through a genuinely diverse, interconnected urban population, jumping between locals and travelers alike without discrimination. Picture the scene inside Jerash during those final catastrophic weeks. A bustling trade city filled with merchants, travelers, and residents from dozens of different backgrounds, suddenly gripped by an invisible killer moving through crowded streets, markets, and homes, faster than anyone could understand what was happening. There would have been no concept of bacteria back then, no understanding of contagion in the scientific sense we have today. Just sudden illness, followed by death, spreading through a community that had no real defense against it. The archaeological pattern discovered at this site closely mirrors something researchers would not see again in written and physical evidence for another 800 years, during the infamous plague pits of medieval Europe. Rapid burial, high-density stacking of bodies, almost no individual funerary structure or ceremony. This striking similarity across such a massive span of time suggests something deeply important about how human societies respond to catastrophic disease outbreaks, whether in the 6th century or the 14th century. When death arrives fast enough and in large enough numbers, formal burial customs simply collapse under the sheer weight of the crisis. According to the lead researcher on this project, the earlier stages of studying this outbreak focused mainly on identifying the pathogen responsible. But this newest phase of research does something far more human. It transforms a cold genetic signal into an actual human story, revealing who these people were, where they likely came from, and how an entire city experienced the collapse of normal life during one of history's earliest recorded pandemics. This discovery also forces us to rethink the broader timeline of pandemic history that most people learned in school. Most of us grew up hearing about the Black Death as history's defining plague catastrophe, the terrifying medieval outbreak that wiped out roughly a third of Europe's population. But the plague of Justinian actually came first, striking the world nearly 800 years earlier, and until this discovery in Jerash, scientists lacked the direct genetic proof needed to confirm exactly how devastating and how genetically similar that earlier outbreak truly was. Now, with confirmed evidence in hand, researchers understand that the very same type of bacterium responsible for the medieval Black Death was already devastating Byzantine cities centuries earlier, causing rapid urban collapse in ways eerily similar to what would happen again centuries later in an entirely different part of the world. History, it turns out, does not just rhyme. Sometimes it repeats itself with the exact same biological villain wearing a different century's clothing. There's also something quietly haunting about the demographic story hidden inside this discovery. Jerash had already been shrinking noticeably in population before this outbreak struck, dropping from a peak of roughly 25,000 residents down to around 10,000 by the time these plague victims were buried. That means the city was already weakened, already more vulnerable, when this rapid, uniform strain of plague arrived and delivered what may have been one of the final devastating blows to an already struggling urban center. This raises an unsettling question that echoes far beyond ancient Jordan. How much of a role did pre-existing urban decline play in making this outbreak so catastrophically deadly? Was Jerash simply unlucky, struck by an aggressive strain of bacteria at a random moment in time, or was it a city already stretched thin, already vulnerable, waiting for exactly this kind of crisis to push it past the point of recovery? The evidence increasingly suggests the answer is a mixture of both misfortune and mounting fragility, colliding at precisely the wrong moment in the city's long history. If stories like this one, where ancient bones reveal secrets that rewrite entire chapters of human history, are the kind of content you genuinely enjoy, make sure you are subscribed, because there are countless more discoveries just like this one waiting to be explored on this channel. What makes the Jerash discovery so significant within the wider scientific community is not simply that it identifies an ancient pathogen. Scientists have identified ancient pathogens at other sites before. What makes this particular find remarkable is the sheer scale of direct evidence recovered from a single location, combined with such detailed information about the actual people who died there. Most ancient disease research relies on scattered remains, single burials, or isolated cases spread across different sites in different time periods. Jerash offers something far rarer, a single tightly clustered snapshot of catastrophe frozen in place for 14 centuries. This level of preservation allows researchers to study something incredibly difficult to capture from history. The actual moment a pandemic overwhelms a functioning society in real time. Instead of piecing together fragments from different eras and different locations, scientists studying Jerash are essentially looking at a single devastating chapter of human suffering, preserved almost, perfectly beneath layers of earthquake rubble and centuries of undisturbed soil. It also raises fascinating questions about how frequently ancient pandemics may have shaped the rise and fall of civilizations throughout history in ways that traditional historical records simply never captured. If a discovery this significant remained hidden beneath a collapsed racetrack for over 1,000 years, how many other similarly catastrophic outbreaks might still be waiting to be uncovered at other ancient sites around the world, quietly reshaping our understanding of exactly how fragile even the mightiest ancient empires truly were? There is something profoundly humbling about standing at the edge of a discovery like this, an empire that once built magnificent colonnaded streets, hosted thrilling chariot races, and connected traders from countless distant regions, ultimately found itself completely powerless against something too small to even see with the naked eye. No army could defend against it, no wall could keep it out. It moved silently through markets, homes, and public gathering spaces, indifferent to wealth, status, or origin, until an entire section of a thriving city had to be buried together in a single desperate mass grave. And now, nearly 1,500 years later, modern science has finally given a voice back to those 230 individuals, revealing not just how they died, but hints of who they actually were, where they may have grown up, and how deeply interconnected their ancient world truly was. Let us slow down for a moment and really sit with the sheer scale of what was found beneath that collapsed hippodrome, because the number itself deserves more attention. 230 individuals layered together in dense chambers is not a small tragedy. It is a mass casualty event on a scale that most modern people struggle to even picture happening in their own lifetime. Imagine an entire neighborhood gone within a matter of weeks. Imagine every household on several streets simultaneously mourning multiple family members with no functioning system left in place to properly bury them one by one. That is the reality frozen inside these two burial chambers, sealed by chance beneath falling stone. The researchers behind this study did not stumble upon this discovery by accident. This was the culmination of years of careful, methodical work, representing the third in an ongoing series of scholarly papers focused specifically on understanding this first known outbreak of bubonic plague in the wider Mediterranean world. Each paper built on the last, slowly assembling a more complete picture, moving from simply detecting the presence of disease toward understanding the full human and societal impact of that disease on a living, breathing ancient city. What is especially remarkable is how this research blends multiple completely different scientific disciplines into a single unified investigation. Archaeologists carefully documented the physical layout of the burial chambers, noting the density and positioning of remains. Geneticists extracted and sequenced fragile ancient DNA from centuries-old teeth, hunting for traces of bacterial genetic material that had somehow survived through 14 centuries of decay. Isotope specialists analyzed the subtle chemical signatures locked inside bone and enamel, reconstructing dietary patterns and childhood geography with a level of precision that would have sounded like science fiction just a few decades ago. This kind of interdisciplinary approach represents a genuine turning point in how ancient pandemics can now be studied. In the past, researchers were often limited to historical texts, written by authors who may have exaggerated details, misunderstood symptoms, or simply lacked the scientific vocabulary to accurately describe what they were witnessing. Now, direct biological evidence allows scientists to bypass potentially unreliable historical narratives entirely, going straight to the source material embedded inside the very bones of the people who lived and died through these events. It is worth pausing to consider just how strange and unsettling it must have been for the people living through this outbreak in real time, without any of the scientific understanding we now take for granted. They had no concept of bacteria, no understanding of how disease actually spreads from person to person through fleas, rodents, or close contact. To them, this must have felt like some kind of divine punishment, an inexplicable curse descending upon their city without warning or mercy. Entire families likely fell ill within days of each other, with no real explanation available beyond fear, superstition, and desperate prayer. And yet, despite that complete lack of scientific understanding, the people of Jerash still made a very human choice in their final response to this crisis. Even without formal ceremony, even without individual graves, they still gathered their dead together rather than simply abandoning them where they fell. There is something quietly moving about that detail, Even in complete chaos, even facing an invisible enemy they could not begin to comprehend, some remaining structure of community and care persisted long enough to ensure these victims were buried together, rather than left scattered and forgotten across the city. This discovery also adds meaningful weight to broader questions. Historians have long debated about the true scale and severity of the plague of Justinian throughout the ancient world. For years, some scholars argued that ancient written accounts of the outbreak may have been exaggerated for dramatic or religious effect, painting an overly catastrophic picture that did not necessarily match the true biological reality on the ground. This physical, genetic evidence firmly settles that debate for at least this particular location. The devastation described by ancient writers was not exaggeration. It was, if anything, a fairly accurate reflection of the genuine horror unfolding in cities like Jerash during this period. Beyond confirming the historical record, this discovery also opens up entirely new avenues for future research across the wider Mediterranean region. If a site this significant remained completely undocumented and unexamined for so many centuries, hidden beneath collapsed stone from an ancient earthquake, it raises an important question for archaeologists and historians alike. How many other ancient cities across this region may be quietly sitting on similarly undiscovered evidence of this same catastrophic pandemic, waiting for the right combination of excavation, funding, and scientific technique to finally bring their stories to light? There is a certain irony embedded within this entire discovery that feels worth reflecting on. An earthquake, itself a sudden and destructive natural disaster, ended up accidentally preserving evidence of an entirely different disaster from centuries earlier. Had that structure never collapsed in exactly the way it did, sealing these remains beneath layers of protective rubble, this mass grave may have been disturbed, looted, or simply eroded away by time long before modern archaeological and genetic techniques ever had the chance to properly examine it. In a strange way, one catastrophe ended up safeguarding the memory of another, allowing modern science to finally reconstruct a tragedy that might otherwise have been lost to history entirely. There is also something worth considering about how this discovery might change the way future generations of students learn about pandemic history altogether. For decades, textbooks tended to treat the Black Death as the dramatic starting point for any serious discussion about how disease can reshape entire civilizations. The plague of Justinian was often reduced to a brief footnote, mentioned in passing, as an earlier, less understood outbreak. With this level of direct genetic and archaeological evidence now confirmed, that footnote deserves to become a full chapter of its own, one that properly acknowledges just how devastating, how fast-moving, and how genetically similar this earlier catastrophe truly was to the disease that would terrify Europe centuries later. It is also worth remembering that behind every statistic, every isotope reading, and every strand of ancient bacterial DNA, there were real individual human beings living through unimaginable fear, parents who watched their children fall ill within hours, travelers who arrived in a bustling trade city full of hope, only to become victims of a disease they could never have anticipated, neighbors who likely tried desperately to help each other, even as the scale of the crisis grew far beyond anything their community had ever experienced before. Science can tell us about strains, isotopes, and burial patterns, but it is important to never lose sight of the deeply personal tragedy hidden within every single one of those 230 individuals. So when we say this discovery rewrites history, we do not simply mean it adjusts a date on a timeline somewhere in an academic paper. We mean it fundamentally changes how researchers, students, and curious minds around the world will understand the true origins, scale, and human cost of pandemic disease throughout ancient civilization. A racetrack built for celebration and spectacle became, centuries later, an accidental tomb and time capsule, preserving one of humanity's earliest and most devastating encounters with a pathogen that would go on to shape the course of world history again and again. And now, nearly 1,500 years later, modern science has finally given a voice back to those 230 individuals, revealing not just how they died, but hints of who they actually were, where they may have grown up, and how deeply interconnected their ancient world truly was. Their story was almost lost forever beneath collapsed stone and centuries of silence. Now, thanks to careful excavation and remarkably advanced genetic analysis, their experience is finally helping rewrite one of the earliest and most important chapters in the entire history of human pandemics.